For decades, humanity has gazed upward, scanning the infinite expanse of the cosmos, not merely for distant planets or faint radio signals, but for those elusive anomalies, glimpses of the universe defying our expectations. We've hunted for signs that challenge the ordinary, whispers from the void that hint at something profound. And now in 2025, the James Webb Space Telescope, JWST, has delivered just such a puzzle with the discovery of 3I/ATLAS, the third confirmed interstellar object to grace our solar system. What started as a routine detection by the Asteroid Terrestrial Impact Last Alert System, ATLAS, telescope in Chile on July 1st, 2025, has evolved into a scientific enigma that's captivating astronomers worldwide. This isn't just another wandering rock or icy comet. It's a massive, ancient visitor from beyond our stellar neighborhood, exhibiting traits that don't quite fit the mold of natural celestial bodies. As data streams in from JWST, Hubble, and ground-based observatories, questions mount. Why is it so unusually massive? Why does its composition raise eyebrows? And could it, dare we ask, be something more than a mere comet? Buckle up, because we're about to embark on a deep dive into the facts, the anomalies, and the tantalizing speculations surrounding 3I/ATLAS. Stick around to the end, where we'll explore what this could mean for our place in the universe and what's coming next in this unfolding cosmic drama. Let's set the stage with the basics of interstellar objects, those rare wanderers that remind us our solar system isn't an isolated bubble. The first, 1I, burst onto the scene in 2017, a cigar-shaped oddity tumbling through space at breakneck speeds, lacking the typical cometary tail and sparking wild theories about its origins. Then came 2I/Borisov in 2019, more comet-like with outgassing but still an outsider from distant stars. Fast forward to 2025, and 3I/ATLAS joins this exclusive club, officially designated as C/2025N1, ATLAS. Discovered as a faint blip near the border of the Serpens Cauda in Sagittarius constellations. It's hurtling toward us on a hyperbolic trajectory, meaning it's not bound by our sun's gravity and will eventually sling back into the interstellar void. Moving at over 60 kilometers per second, about 134,000 miles per hour, it's a relic potentially 7 billion years old, hailing from the Milky Way's thick disk, a region teeming with ancient stars. This makes it possibly older than our own solar system, which clocks in at around 4.6 billion years. Imagine that. A cosmic time capsule, forged in the fires of a long-gone star system, now paying us a fleeting visit. But as telescopes locked on, the initial excitement gave way to intrigue. Unlike its predecessors, 3I/ATLAS is brighter, bigger, and behaving in ways that challenge straightforward explanations. Its magnitude hovers around 12 as of late September 2025, visible only through powerful scopes, but projections suggest it could brighten to magnitude 11 by December, offering amateur astronomers a shot at glimpsing it. Yet its steady glow and lack of dramatic flaring hint at something unusual, almost as if it's holding back secrets. The James Webb Space Telescope, humanity's most advanced eye on the universe, positioned at the L2 Lagrange point about 1 million miles from Earth, was built to unravel such mysteries. Launched in 2021, JWST's infrared capabilities allow it to pierce cosmic dust and detect heat signatures invisible to optical telescopes like Hubble. On August 6, 2025, JWST turned its near-infrared spectrograph, NIR spec, toward 3I/ATLAS, capturing data that has since sent ripples through the astronomical community. What it revealed wasn't the expected mix of ices and dust typical of solar system comets. Instead, the comet's coma, the hazy envelope of gas and dust surrounding its nucleus, was dominated by carbon dioxide, CO2, with traces of water ice in the core and an unexpected abundance of nickel. This composition is peculiar. While CO2 is common in some comets, the high levels here suggest 3I/ATLAS formed near the CO2 ice line in its original protoplanetary disk, or endured intense radiation exposure during its interstellar journey. Hubble, complementing JWST, snapped images on July 21, 2025, when the object was 277 million miles from Earth, revealing a teardrop-shaped bluish cocoon of dust, enveloping a nucleus estimated at 3.5 miles to over 6 miles across, far larger than initial predictions. But the real shocker? A recent study pegged its mass at a staggering 33 billion tons, 3 to 5 orders of magnitude heavier than Oumuamua or Borisov. This major anomaly, as dubbed by researchers, defies expectations for interstellar objects, which are typically lightweight fragments. Why so massive? Scientists speculate it could be a chunk from a disrupted planet or a primordial body preserved in the cosmic deep freeze. Yet this heft implies resilience. 3I/ATLAS has survived eons of radiation, gravitational tugs, and now, as it nears our sun, intense solar winds without crumbling. As observations piled up from over 227 global observatories by September 23, 2025, a fuller profile emerged and it painted 3I/ATLAS as anything but ordinary. Its trajectory is remarkably flat and straight, aligned with the ecliptic plane, the orbital path of our planets, with odds estimated at 1 in 500 for a random interstellar visitor. This precision raises eyebrows. Is it coincidence or something more? Non-gravitational acceleration, a subtle push not explained by gravity alone, has been detected at less than 15 meters per day squared. In comets, this often stems from outgassing, jets of sublimating ice acting like tiny thrusters. But for 3I/ATLAS, the effect is muted, perhaps due to its massive nucleus resisting change. Outgassing is evident, with a mass loss rate of about 150 kilograms per second. Yet it's not producing the dramatic tail we'd expect. Instead, its coma expanded rapidly from 13,040 kilometers on June 21st to 18,760 kilometers by July 2nd, spanning dimensions twice Earth's diameter. Adding to the oddities, 17-minute oscillations hint at rotational behavior or internal structure. And then there's the brightness. It's increasing quickly, defying models for a standard comet. Ground-based telescopes in Chile and elsewhere have noted early activity as far out as 6.4 astronomical units from the Sun, 2 months pre-discovery, suggesting it's more volatile than anticipated. These traits collectively form a puzzle, a body that's comet-like but amplified, ancient yet active, massive yet maneuverable. As we approach its Mars flyby on October 3, 2025, NASA's Mars Reconnaissance Orbiter, MRO, with its high-rise camera is poised to capture close-ups, potentially revealing surface details. But what if these anomalies point to something engineered? Hold that thought. We'll circle back to the Wilder theory soon. Diving deeper into the science, let's unpack why 3I/ATLAS's composition is turning heads. Spectroscopic data from JWST shows a CO2-heavy coma, which could mean it originated in a star system with different chemistry than ours. In our solar system, comets like Hale-Bopp or Hyakutake are rich in water and methane. But CO2 dominance is rarer, often linked to formation farther from a star where carbon monoxide freezes out. The nickel abundance without corresponding iron is another quirk. Natural processes typically pair them, but here it's skewed. Some hypothesize quantum confinement or intense magnetic fields in its birth system synthesize these materials unnaturally. Harvard astrophysicist Avi Loeb, known for his bold takes on Oumuamua, rates 3I/ATLAS a 6 out of 10 on his Loeb scale for potential artificiality. In a preprint paper, he posits it could be a technological artifact, perhaps a probe or even a mothership, given its size, path, and non-gravitational push. Loeb argues the alignment with our ecliptic allows optimal reconnaissance of inner planets, and its retrograde tilt opposite our orbital direction is low, unusual for random interstellar drift. He even floats possibly hostile intentions, though he frames it as a pedagogical exercise to spur discussion. Mainstream astronomers push back, attributing anomalies to natural physics. The mass could result from it being a super comet like Bernardinelli-Bernstein, the trajectory, a statistical fluke, the acceleration, uneven outgassing. Yet Loeb's voice amplifies public fascination. After all, if it's tech, it could be harvesting solar energy or transmitting data home. Imagine the implications. A self-sustaining craft, dormant for eons, awakening near a habitable system like ours. Building suspense, recent events have added fuel to the speculative fire. As 3I/ATLAS barreled inward, it reportedly shrugged off a solar coronal mass ejection, CME, a massive burst of plasma from the sun. A typical comet might fragment or lose its tail, but this one held steady, its path unaltered. Social media buzzed with claims of a weird green glow and links to the 1977 WOW signal, a mysterious radio burst some tied to its origin direction. While unverified, these anecdotes echo the prompt's fictional pulses. In reality, no confirmed signals have been detected, but SETI Institute teams have scanned frequencies, finding only noise. Still, what if? Loeb suggests international protocols for such encounters, urging we prepare philosophically and scientifically. NASA's vague statements on instrument recalibrations, post-JWST observations, have sparked conspiracy whispers, though likely routine. Leaked documents? None confirmed, but internal memos from ESA and NASA hint at coordinated monitoring. As it nears perihelion around October 29th to 30th, 2025, at about 0.9 astronomical units from the Sun, brightness could spike, revealing more. Then Earth's close approach in late October, safely at 1.8 astronomical units, no collision risk, followed by Venus and Jupiter flybys. Juno spacecraft might observe the Jupiter encounter in March 2026, potentially detecting magnetic anomalies or emissions. To truly engage, let's step back and contextualize this within humanity's quest for extraterrestrial intelligence, ETI. The search for extraterrestrial intelligence, SETI, began in the 1960s with Frank Drake's Project Ozma, scanning stars for radio signals. Decades later, we've sent our own messages, like the Arecibo broadcast in 1974 or Voyager's Golden Records, hoping for a reply. Oumuamua reignited debates when Loeb proposed it as a light sail probe in his book, Extraterrestrial. Borisov, more comedy, tempered that, but 3I/ATLAS revives it with fresh data. If artificial, it could be a von Neumann probe, a self-replicating machine exploring galaxies. Theoretical models suggest such craft could traverse the Milky Way in millions of years, seeding or observing. But probability is low. Estimates peg interstellar objects at 60 within Jupiter's orbit at any time, mostly small. Detecting a large one like this is rare, amplifying anomaly perceptions. Philosophically, it challenges our anthropocentrism. Are we alone? If not, why the silence? The Fermi paradox. Perhaps ETI lurks quietly, observing like 3I/ATLAS might be. Darker theories posit surveillance or evaluation, but evidence lacks. Instead, focus on science. Studying it advances understanding of exoplanetary chemistry, interstellar travel hazards, and planetary defense. Expanding further, consider the technological feats enabling this discovery. The Atlas system, funded by NASA, scans for near-Earth threats but snag this interstellar gem. JWST, a $10 billion marvel from NASA, ESA, and CSA, uses its 6.5-meter mirror to resolve details at infrared wavelengths, cutting through dust. Hubble, at 35 years old, provides optical complements. Future tools like the Vera C. Rubin Observatory, now online, could spot more such visitors. International collaboration shines. Data from Chile, Hawaii, and space assets flow to the Minor Planet Center. Quotes from experts add flavor. Avi Loeb, we should be happier considering alien tech. It inspires. NASA officials counter, it behaves like a natural comet. Debates rage on forums, with X, formerly Twitter threads, dissecting oscillations as possible telemetry. One post noted its coma growth as camouflage, speculative but engaging. As October 3rd nears, MRO's high RISE could image craters or structures if any exist. No, we're not claiming aliens, but the what if keeps us hooked. Pushing word count, let's explore historical parallels. Comet Halley in 1910 sparked panic with cyanogen gas fears. Oumuamua's 2017 flyby inspired books, documentaries. Now 3I/ATLAS fuels YouTube videos, podcasts, yours truly encouraging full watches for the payoff. Implications ripple. If natural, it seeds systems with organics, aiding life. If anomalous, it boosts SETI funding. Politically, Representative Anna Paulina Luna urged extending Juno for intercept. Impractical but bold. Defense angles. Space Force's X-37B launch in August 2025 included quantum navigation, coincidental. No evidence of threats, but preparedness matters. Philosophically, it humbles us, Earth's a speck. Religiously, some see divine creation, others multiverse proof. Educationally, it sparks STEM interest. Kids calculating trajectories, debating origins. As we near the climax, recent updates. By September 30th, 2025, 3I/ATLAS is 2.4 astronomical units out, magnitude 12, with 17-minute rotations confirmed. No signal pings, but if SETI tried, hypothetically, a 72-hour delay response would chill. Pure fiction here. Technical glitches, routine calibrations, not jamming. Patterns, its path mirrors no Fibonacci, but math underpins all. Consensus. Natural, but anomalies persist. In conclusion, 3I/ATLAS isn't just a comet, it's a catalyst reigniting wonder. From JWST's revelations to Loeb's speculations, it challenges assumptions. We've glimpsed the unknown, and as it flies by Mars, Earth, beyond, stay tuned. What if this is first contact's whisper, or merely nature's majesty? Either way, the universe beckons. Watch to the end. Next could be revelation.